Imagine a starship not protected by cold metal hulls or shimmering energy fields, but rather by a living, responsive membrane grown in vats and tailored to the very perils of the cosmos. This is the world of biological force fields, living shields that redefine defense and adaptation in the age of deep space travel. In this sci-fi future, scientists have mastered synthetic biology to such a degree that they can design complex, robust organisms at the cellular and even subcellular level. Rather than constructing shields, they cultivate them. These bioengineered barriers consist of densely layered cellular tissues modeled after the toughest creatures on Earth: tardigrades, extremophile bacteria, and deep-sea organisms. These tissues can self-repair rapidly. If a micrometeor breaches part of the shield, the surrounding cells immediately begin to regrow and seal the wound, much like our own skin heals from a cut, but orders of magnitude faster. What truly separates living shields from passive barriers is their ability to sense and adapt. Embedded within their membranes are biosensors, proteins tuned to various wavelengths and types of damage, ionizing radiation, EM pulses, even chemical contamination. The shields can secrete protective gels, increase pigmentation, or even alter their molecular structures, much like cephalopods can change their texture and color for camouflage to defend against novel threats. Some even carry colonies of engineered symbiotes, a biolayer populated with microorganisms that consume hazardous particles and toxins, providing not only passive protection, but active purification of the space habitat's environment. Need a more formidable defense? These living force fields can be induced into a state of hyperreactivity, a controlled biological response akin to inflammation, toughening their surface and creating additional layers in response to incoming threats, whether it's a burst of cosmic radiation or a swarm of nanomachines. On the speculative science front, progress in real-world fields like CRISPR gene editing, synthetic tissue engineering, and the design of self-healing materials lays the foundation for such wonders. Scientists are already working on self-repairing plastics and engineered organisms that clean up toxins. Living shields of tomorrow could be the ultimate expression of these developments. In the future, the boundary between machine and organism could blur entirely, with space explorers cocooned in customized envelopes of living armor, symbiotic, responsive, and ever-adaptive, the ultimate proof that in the harshest environments, life doesn't just survive, it shields, adapts, and thrives.